Imagine an entire storage array failing right in the middle of your company's busiest day, and absolutely no one notices. Today, we're diving into the HPE infrastructure that makes that kind of zero downtime magic possible to get you fully prepared for the HPE0-J83 exam.
Right, so just to set the stage for you, this is a proctored exam. You'll have exactly 1 hour and 30 minutes to complete 60 questions, and you need a 63% score to pass. Oh, and it is available in English, Japanese, and Korean.
Question 1. What is the primary benefit of using thin provisioning in an HPE storage environment?
The correct answer is A. So thin provisioning improves storage utilization by allocating physical capacity only when data is stored, which really reduces wasted capacity.
Right, so since the host operating system, thinks it has this massive logical volume, how does the storage controller actually manage that mapping without accidentally running out of physical blocks?
Well, the controller dynamically assigns storage in small chunks or pages purely on write operations. So it intercepts those writes and updates a metadata allocation table.
Meaning the physical footprint matches the actual data footprint.
Exactly, yeah, rather than just the promised capacity.
Question 2. A customer wants an on-premises storage solution, but prefers a pay-per-use financial model that scales with their actual consumption. Which HPE offering meets this requirement?
The correct answer is B. HPE GreenLake is basically an as-a-service model that combines cloud-like scalability with local deployment.
I mean, I understand the cloud billing aspect of it, but setting up local hardware still requires a physical deployment.
Yeah.
How can HPE meter that as pay-per-use if the gear is already, sitting in the customer's data center?
Because HPE actually installs a buffer of extra capacity ahead of demand. The metering software tracks the active workload at the storage OS level.
Oh, so the invoice only reflects the gigabytes that are actively processing data.
Right, exactly. That extra local hardware just sits there to seamlessly absorb sudden workload spikes.
Question 3. Which storage area network zoning method uses the unique hardware address of the host bus adapter, allowing the server to be moved to different switch ports without reconfiguration?
The correct answer is C. Worldwide name zoning uses unique hardware addresses to tie zoning policies to device identity, maximizing your deployment flexibility.
Okay, but historically, port zoning was the default because it was so much simpler to set up at the switch level. Why take on the administrative overhead of managing 64-bit hexadecimal WWN strings?
Well, mainly because port zoning breaks down during hardware maintenance. If a technician, say, unplugs a cable and moves it to a different port on the fabric.
Our port zone server instantly loses access to its storage.
You got it. But WWN zoning authenticates the physical card itself, which allows the routing fabric to dynamically adapt, regardless of any physical topology changes.
Question 4. An administrator needs a tool that uses cloud-based machine learning to predict and prevent storage infrastructure issues before they impact the business. Which HPE solution should be used?
The correct answer is D. HPE InfoSight uses cloud-based AI to proactively monitor health and basically prevent workloads from being affected.
Now, predictive analytics is kind of a major buzzword. What makes InfoSight's machine learning functionally different from just a standard SNMP monitoring system that sends alerts when a threshold is breached?
Well, traditional monitoring triggers after a failure has already happened. InfoSight actually aggregates telemetry data from thousands of arrays globally.
Wait, so it looks at everything together?
Yeah, its cross-stack analytics engine identifies micropatterns like maybe a specific VMware latency tied to a particular firmware version, and then it automatically deploys signatures to prevent that exact bottleneck.
Before the degradation even occurs on your array.
Exactly.
Question 5. A customer needs to back up database servers to an HPE Store Once appliance over a slow, wide area network. Which feature should be used to deduplicate the data at the source server before transmission?
The correct answer is A. Store Once Catalyst removes duplicate blocks at the source, saving bandwidth over slow networks.
But if we're performing source-side deduplication, aren't we just, offloading the computational burden onto the production database server?
You'd think so, but the CPU hit is actually minimal compared to the I/O bottleneck of a slow WAN. Catalyst calculates cryptographic hashes for the data blocks right at the source.
So it just queries the Store Once appliance with those hashes.
Exactly. If the appliance recognizes the hash, it already has the block. So the source server only transmits a tiny pointer, basically eliminating any redundant payload transmission.
Question 6. What is the most critical prerequisite that must be verified on all connected host servers before performing a non-disruptive storage controller firmware upgrade?
The correct answer is B. Redundant multipathing provides multiple active paths, ensuring uninterrupted storage access during firmware upgrades.
I mean, doesn't running multiple active paths introduce the risk of SCSI reservations or maybe I/O conflicts if two paths write to the same logical unit simultaneously?
Well, that is exactly why the multipathing software layer is totally mandatory. It essentially acts as a traffic director at the host OS level.
Oh, so it abstracts the physical paths to present just a single virtual device to the application.
Right. Intelligently load balancing and instantly rerouting I/O if a controller node goes offline for its firmware flash.
Question 7. Which HPE storage feature enables transparent failover of host input and output operations between two different storage arrays in a metropolitan area network without application interruption?
The correct answer is C. HPE peer persistence enables automatic failover between synchronized arrays in a metropolitan network to prevent application downtime.
For that failover to be truly transparent, though, how does the secondary array trick the host into thinking it's still talking to the primary array?
It utilizes asymmetric logical unit access, or ALUA. The secondary array presents the exact same worldwide name and volume serial number as the primary.
Oh, wow. So when the quorum witness detects a site failure?
It instantly switches the target paths on the secondary array to active, and the host's multipathing software simply resumed operations without a single application error.
You now understand the structure of the HPE0-J83 exam and the key principles behind HPE's provisioning, droning, and high availability features.